We are going to talk about polynomial functions in this video. So, polynomial functions. A polynomial function is a function that can be written in the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus and so on through a1x plus a0, where the ai's are real numbers, a sub n is not equal to 0. N is a non-negative integer and is called the degree of the polynomial. It's basically the degree of the highest term in our polynomial. Now, we're going to talk about a couple of features of polynomials. First, we have what's called a turning point. And a turning point is a place where the function switches from increasing to decreasing or vice versa, so decreasing to increasing. So the function's going down and then it turns up, or the function's going up and then it turns down. Now, a polynomial of degree n can have at most n minus 1 turning points, but may have fewer. So, for example, we've looked at quadratic functions before. A quadratic function can have at most, and in fact actually has, exactly one turning point. A cubic function might have, again, a cubic function has degree 3, and a cubic function might have no turning points. It might have 2 turning points, but that's it. It can't have more than 2, and so on. So a polynomial, if it's got even degree, it must have at least one turning point. So let's look at some functions and ask ourselves, what is the minimum degree of this function? Well, it's got one turning point, so the minimum degree is 2. Doesn't mean it can't be bigger than 2. It could be 4, it could be 6, it could be 8. And we'll see in just a minute it cannot have odd degree, but basically the minimum degree that this function can have is 2. We look at this function and we count the turning points. We can see 1, which is at about -2. We've got a second one, which is at about -1, and we've got a third one, which is at about 0. So there are 3 turning points, which means the degree of this polynomial must be at least 4. And then finally, we have this polynomial, and we can see a turning point at about -1.5, a turning point at -0.5, a turning point at about 0.5, and a turning point at about 2.5. So there are 4 turning points of this function. Remember, a turning point is when it goes from increasing to decreasing or decreasing to increasing. So 4 turning points means the minimum degree of this polynomial is 5. The other thing we should think about with a polynomial is the end behavior. And this differs as to whether or not the degree of the polynomial is even or odd. If the degree of the polynomial is even, then as x becomes very large and positive, we are going to have the largest term is x to some power n, where n is even. That's going to be even bigger and positive if a sub n is positive, and bigger and negative if a sub n is negative. So the polynomial with even degree becomes large and positive if a sub n is positive, and large and negative if a sub n is negative. A polynomial, so that's as x gets really, really big and positive. When x gets really, really big and negative, the same happens, because you're taking the largest, the leading term, which has the highest degree, dominates, becomes the biggest. And again, you square or take to the 4th a negative number, that becomes a positive number. So a polynomial with even degree, as x becomes large and negative, then the polynomial becomes large and positive if a sub n is positive, and negative if a sub n is negative. Now the end behavior for an odd degree polynomial is the same as x becomes large and positive, but differs when x is large and negative. So as x becomes large and negative, the polynomial becomes large and negative if a sub n is positive, and large and positive if a sub n is negative. So we can look at this function and we can say to ourselves, well, as x becomes large and positive, the polynomial is getting larger and larger. So that's true both for an even degree polynomial and an odd degree polynomial. As x becomes large and negative, though, this function is becoming positive. That means this function must have even degree, because if it was odd degree, then the function would become large and negative. This is the same, right? As the function becomes large and positive, the function gets bigger and bigger. That's true for a positive degree an even degree or odd degree polynomial. But again, as x becomes large and negative, we see the function becoming positive, which means the degree is even. And again, same feature here. Okay, so let's look. Find the degree of the polynomial, the x-intercepts, and the y-intercepts. Okay, so we have a polynomial here. We want to find its degree. Well, that's going to be the degree of the highest degree term in the polynomial if we multiplied all this out. Now, we don't have to multiply it out. We just have to figure out the degree. So that first term is x to the fourth. The second term, the x minus 2 squared, is going to, if we multiplied it out, have an x squared term in it. X to the fourth times x squared is x to the sixth. So that is degree 6. The x-intercepts are where the function is 0. Well, we can see we've already factored this polynomial. So the function is 0 at 0, and the function is 0 at 2. So those are our x-intercepts. The y-intercept is when x equals 0. And again, the y-intercept here is 0. Okay, this is a more complicated polynomial. G of x equals x squared plus 2x plus 12 to the fourth times 2x plus 2 cubed. Well, to find the degree, first what we do is we say what's the largest degree term in that first term, and that would be x to the 8th, right? X squared to the power 4 is x to the 8th. In the second term, we have 2x to the power 3, so that's going to have degree 3, so that's going to be an 8x cubed. So x to the 8th times 8x cubed, that's going to be 8x to the 11th, so the degree is 11. Now we need to find the x-intercepts and the y-intercepts. Well, the y-intercepts are pretty easy. We plug in 0, and we get 12 to the fourth times 2 cubed, which is some big number. We could figure out what it is. The x-intercepts, well, one of them is easy. We can look at that second term, 2x plus 2 cubed, and we can say, well, when x equals -1, that's equal to 0. The first term's a little harder. We've got a quadratic equation here, but we go back and we look at the discriminant, b squared minus 4ac. Well, b squared minus 4ac, b squared is 4, minus 4ac is 4 minus 48. Well, that's negative, so there are no x values that make x squared plus 2x plus 12 equal to 0. So the only x-intercept here is -1. Okay, so what happens to the following polynomial? As x goes to infinity and as x goes to -infinity. X becomes really large and positive, and x becomes really large and negative. All right, we look at that first term, right? The leading term is all that matters, right? And the point is, the leading term is all that matters because once x gets really big, then 3x cubed is much, much bigger than 3x squared or 3x or 3. So all we care about is that 3x cubed. So we look at when x is really, really big and positive, well, 3x cubed is going to be really, really big and positive. So as x gets really big and positive, h of x gets really big and positive. As x gets really big and negative, though, again, that first term, the leading term dominates, but now we've got an odd degree. So negative, let's choose a number, -1,000,000. -1,000,000 to the power 3 is a really big negative number, so h of x is going to get really big but negative. All right, let's look at g of x. G of x is -3x to the fourth minus 3x squared minus 3x plus 3. Again, the only term that matters as x gets really big is that first one, the leading term, the one with the highest degree. As x gets really big and positive, x to the fourth gets really big and positive, but we're multiplying by -3, so g of x gets really big and negative. And again, as x becomes really big and negative, g of x again becomes really big and negative. For our final problem, we're going to look at the maximum and minimum number of x-intercepts that a polynomial can have. So we're going to look at degree 7 and degree 6. And the thing to remember here is that a polynomial of degree 7 can have at most 6 turning points. So I'm going to draw a function or a polynomial with 6 turning points. So if we're going down, we turn once, twice, 3 times, 4 times, 5 times, 6 times. So there's a function with 6 turning points. Now, the most x-intercepts is going to be when the x-axis is somewhere here. And we've got 1, 2, 3, 4, 5, 6, 7. So the maximum number for a polynomial of degree 7 would be 7. The minimum number, let's say the x-axis were here. The minimum number would be 1. And so the number of x-intercepts that a polynomial of degree 7 can have is somewhere between 1 and 7. Polynomial of degree 6, the most turning points is 5. So let's draw that. We go down, 1, 2, 3, 4, 5. Again, if the x-axis is here, we get 1, 2, 3, 4, 5, 6. If the x-axis is here, though, we get none. So here, polynomial of degree 6 has between 0 and 6 turning points.